I have shown you earlier that this energy dissipation is numerically equal to so I am considering the energy dissipation per unit cycle. That means this is 0 to 2 pi by omega, and this is numerically equal to, and this I have proved that this is 2 pi by omega and f t x dot t dt. Okay, so this one you can easily prove from the equation of motion and then writing down the integral. So here I have the expression. Now this is equal to 0 to 2 pi by omega and then ft dxt. So what is this one? So this is equal to so because x dot equal to dx by dt, so therefore this has to be so. Now if you look at this expression, this is nothing but area under the integral, area under the curve, which is drawn in the fxt plane. So at different point of time, suppose you plot at different instance of at suppose t, you find out. So what I am doing, I am considering here, let us say f t and xt here. So at one point of time, suppose I have the at one point on time t, suppose I know the function ft, that is equal to f naught cosine omega t. So I know what this one, and x I know. So this is f at time t, and x at time t will be equal to x naught, let us say whatever, cosine omega t minus 5. So here, so this one I can find out. So this will be at one point of time, this will be, you can find out the value of t and xt and plot this one and draw this point. So in that way, if you draw all the points for different time, so then it will get a closed curve, right? And this closed curve, so because the closing, because this is a overall, this is a periodic function, so therefore at after 2 pi, so if you start from any t, then after 2 pi by omega plus t, you must get back the same point, because this is actually a harmonic, two harmonic functions of same frequency. So it will come back to this one point, so this becomes actually a closed curve. Now what it says that the area under this closed curve, this is numerically equal to the energy dissipated. Okay. And this kind of closed curve which we are having in the fx plane, this is known as a hysteresis curve. So this is hysteresis. So this numerically, this phenomenologically, it is called hysteresis because hysteresis is a phenomena where the curve is not traced while coming back. So therefore, so if suppose it increases, so one simple example of this hysteresis is that suppose there is it is going this way while increasing, suppose x and y, it is increasing this way, it is coming back and like that. So therefore, while going up, it takes one path, while coming down, it takes another path, and it closes an area. So this is known as the hysteresis. So similar phenomena occurs, and we also call the hysteresis here. So we have the hysteresis phenomena, and now let us see what kind of curve it will generate. So what we have to do, that is what is that we are doing is that I am finding out, I am drawing all the points in the t in the xf plane and getting the curve. So that means that here I am removing t, because this curve which you get from here, this different points corresponds to different value of t, and therefore when you want to draw the curve, what we'll have to see, what we have to get, that this t is actually acting like a parameter of this curve. So the equation of this curve can be obtained if you eliminate t from these two expressions. So let us do that exercise. That will be a little bit mathematical, but let us do this exercise. So what we are doing, we have ft, which is equal to f naught cosine omega t, okay, cosine omega t, and xt, which is equal to f naught by k and f cosine omega t minus phi, where f is a known function of frequency and phi is also a known function of frequency. So if you eliminate t from here, so therefore we have f square will be equal to, so x square, let me first So x square will be equal to f naught by k f square, and cosine square. I should do that first. Okay, let me f naught by k. So let us denote x divided by f naught by k times f. Okay, this is equal to cosine omega t cosine phi plus sine omega t sine phi. So cosine omega t, this is nothing but f by f naught. This is equal to cosine omega t cosine phi plus sine omega t plus sine omega t sine phi. So what we'll have to do now is that uh, either you can substitute sine over there, or okay, so sine omega t, so therefore this will be equal to x divided by f naught by a f minus f naught f by f naught cosine phi. This is equal to this square will be equal to sine square omega t, which is equal to, so this will be equal to sine square omega t sine square phi, which is equal to 1 minus cosine square omega t sine square phi, and cosine square omega t is nothing but f by f naught. So you get this expression x minus x divided by f naught by kf minus f by f naught cosine phi